Okay, so this question asks, what are the units for the rate constant of a reaction with the rate law? Rate equals the rate constant times the concentration of A times the concentration of B. So here's the way that I think about this question. We know, as it says above, that the rate, okay, and it has units of molarity per second. So that's what we're shooting for. We're looking for units of molarity per second. And those units are going to be provided by everything else on the right side of the equation. So the rate constant times the concentration of A times the concentration of B. Okay? So we're asking, what are the units on the rate constant? So I'm just going to leave a blank for that. But I know that the units on A are going to be units of molarity because it is a concentration. And I know that the units on B are also going to be molarity because it is a concentration. And what I need, after all of this is multiplied together, I need it to be molarity per unit of time, in this case seconds. It doesn't have to be seconds, it could be minutes, hours, days, whatever. So I know I want to keep one of these, but one of them needs to go away. One of them needs to be canceled. And I have nothing on the right side of the equation so far to give me that units of per second. So I know that the units of the rate constant are going to have seconds in the denominator. That's one thing that they have to have, because these two guys don't provide those units. But the other thing that I need to do with the rate constant is I need to cancel out one of these molarities, because I can only have one after all the math is done. So I need to put a unit of molarity in the denominator also, so that one of these will cancel and I end up with units of molarity per second. Okay, so molarity per second equals molarity per second. And so then in this case, that means that the units of K have units of, and it would be some number with units of 1 over molarity per second, or another way of writing that is molarity to the minus 1 times seconds to the minus 1, or inverse seconds, inverse molarity. You'll hear that kind of terminology as well. But the idea here is that the rate constant just gives us the units, or it has the units that we need in order to get the units of molarity per second when everything on the right side of the equation is multiplied together. And for a second order reaction, this is what it will be, because this is a second order reaction. Remember, you add the exponents together and that gives you the order of the reaction overall. So for first order reaction, it won't be this. For a third order reaction, for a zero order reaction, it won't be the same. Every order of the reaction is going to have its own unique units for the rate constant.